Hi guys, so we are going to tackle the next topic up in Calculus 1, which almost always follows. You've had your product rule, your chain rule, your quotient rule. Now we're going to move into something kind of a different gear. It's still finding derivatives, but it's called implicit differentiation. So implicit diff is how I abbreviated that. Now the difference here is up until this point, you've always had f of x equals something, some kind of big mess, or y equals some kind of big mess. Now your equations are going to have y's and x's kind of all mingled together. So the first example I've given you, I have 9y squared equals 3x cubed plus 7. Now you say, well, easy, I could just solve this equation for y and then go from there, find y prime, right? Well, that would be all well and good, except when you get y by itself, you're going to have a square root with it, which is a big fat radical, and that's going to be messy, messier than it needs to be. Also, when I do more examples, I'm going to have x's and y's really mixed together, and you're going to need another way to find the derivative without solving for y first. And this is what implicit differentiation does for you. So let's go ahead and get started. The main difference with implicit differentiation is when you take the derivative of a y term, you basically just have to tag on a dy dx. So if I say, if I'm taking the derivative with respect to x, that's what this notation means. I'm taking the derivative of, let's say, a 10y cubed. The derivative of this, now the power rule still applies like normal, so that is going to be 30y squared. But then this is kind of like a chain rule idea where we also have to take the derivative of the inside being y. We have to take the derivative of y with respect to x. So that's where a dy over dx just kind of gets tagged on. When you take the derivative of a y term, a dy dx just kind of tags on, okay? That says that you're taking the derivative of y with respect to x, okay? That's what that means. Up until now, you've taken everything, every derivative just with respect to x, meaning 3x cubed becomes what? 9x squared. That's the derivative with respect to x, just the power rule, and you're done. But when you take the derivative of y with respect to x, you have to tag on the dy dx. Now, also worthy of note is many instructors will show this as 3y squared y prime. That's how a lot of textbooks show it. I do not like that, and I'm going to encourage you not to, instead of saying y prime, say dy dx, because what does y prime look like? It makes your brain work harder because is that y prime? Is that y to the first? Is that just a y if your apostrophe is too little? So go ahead, when you tag on the derivative of y with respect to x, I would say make it a dy dx because it's obviously different. The y prime just can get blended in too easily, if that makes sense. Okay, so those are the basics of implicit differentiation. Let's do an example, and then we'll do more examples piling on so you can get, as the calculus gets more complicated, you can see how you can tackle it. All right, so we have 9y squared equals 3x cubed plus 7. The derivative of 9y squared, power rule like normal. So that's going to be 18y to the first, but you took the derivative of a y, so you have to tag on the dy dx, just like that. Now this equals 3x cubed. You could have done this weeks ago. This is just going to be 9x squared, and then the derivative of 7 is 0. So remember, you don't even really have to write it. Just remember, you do still take the derivative of those constants every time, and it becomes 0. Now, the next thing is we still want, when we find a derivative, we still want to find y prime equals, or dy over dx equals. We got to get that dy dx thing all by itself. So once you've taken the derivative of everything, you just get dy dx by itself. So in this case, we are just going to divide by 18y. So that cancels there. And we have dy over dx equals 9x squared over 18y. Obviously, you can reduce that if you need to. X squared over 2y would be your derivative. So that's implicit differentiation in a nutshell. Keep coming back because we're going to do more, way more complicated things, because you will get into product rules and quotient rules and chain rules, using trigonometry, all that good stuff within implicit differentiation. So keep coming back. I will give you lots more examples. Thank you.